Okay, everybody, in today's video, I'm going to finish off the Edexcel Maths 2023 May Paper 1. We're going to continue with question 18, okay? But before we do continue, I just want to say a big thank you to Kaira. I'm sorry if I'm pronouncing it wrong. Thank you so much. You're totally right for question number 12. So she says, for question 12, since the question states at least, you're supposed to consider Martha losing both games. So after adding all three probabilities, the answer should be 62 out of 72, right? So I'll show you what she means, just in case you don't understand. For question number 12, in the second video, in part 2, I made a major mistake. How we considered all possible events, right? We said, okay, for the first event, she either wins, which is 5/8, multiply losing, right? So 7/9. So that's the first thing that could have happened. That's one of the first possible events, right? The second one is that she loses, but then she wins one because she has to at least win one. So it's 3/8 times 7/9. But we didn't even consider the third event, right? And the third event, possible event, is that she loses both. Because it clearly says, thank you so much, Kyria, that she will lose at least one game. Her losing both games is at least losing one game. So we consider 3/8 multiplied by 7/9 because they can lose both. So 3/8 multiplied by 7/9. So the first event could happen, or the second one, or the third one. So when we have or in probability, we add them up. And of course, so we'll have 35/72 plus 21/72 plus 21/72, right? So if you add up all these, you do get 62 out of 72. And this should have been the final answer. And I just want to say again, thank you so much to Cairo for taking out that mistake. Anyway, let's continue with the paper, okay? Okay, question number 18. So for this question, everybody, it's a typical ratio question, right? And it's like kind of simultaneous equations, right? You really have to look out for these questions because at first it kind of looks difficult, but really it isn't. And it's for 4 marks. So at first, I'm going to quickly define my terms. And it's always important after reading, obviously, I'm assuming you've read this question and you've really had a go at it and you've really tried problem solving, right? You've really sat there and tried to think about it, not just straight away watch the video for the solutions. So I'm going to say that 1 kilogram of carrots is equal to C. Yeah, is C. I'm defining my terms. Is C. And 1 kg of tomatoes is T. So in the first statement, we have 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of 480 pence. So 7 kilograms of carrots, because remember, 1 kilograms of carrots is C. So 7 kilograms is 7C plus 5T is going to give you 480 pence. Okay, cool. Now it says the cost of carrots, 1 kilogram of carrots, the cost of 1 kilogram of tomatoes is 5 to 9. You really have to remember through your studies the relationship between ratio and fractions. So I'm going to say C over T, because remember, we've defined it. 1 kilogram of carrots is C, and 1 kilogram of tomatoes is T. It's equal to 5/9, where C is the 5 and the T is the 9, right? In its relationship here. So then I can solve and say C, or you could, you're going to say C is equal to 5T/9. Is that understood, everybody? Because I've times both sides by T, right? Just in case, I'm just going to look. So I've times, because I've times, it used to be, I've times this side by T and this side by T. So if you put it over 1, the T's here are going to cancel out. So you're just left with C is equal to 5 times T is 5T. 9 times 1 is just over 9. Okay, cool. So now I can go back and I'm going to rub this out, but you guys don't rub it out in the exam. I just have to rub it out because, well, I don't have space. But obviously, you're not going to rub out your working out. So now I'm going to plug. So I'm going to tell the examiner, I'm going to define this as equation 1. This is equation 2. So I'm going to tell the examiner, plug 1 into 2. or rather the other way around. I do apologize. Plug 2 into 1. By the way, guys, if you're watching this video, my students are not in the live class, okay? I'm just doing this off record, I'm doing this in my spare time. So that's why you don't get to hear them coming in and trying to grill me. Okay? All right, cool. Now what? So 7 times C, but we know what C is. C is 5t over 9. Plus 5t is equal to 480. 7 times 5t is 35t over 9 plus 5t is equal to 480. At this point, because I don't like that fraction, I'm gonna times the whole equation by 9. So what am I gonna get? I'm gonna continue working here, okay, guys? Because if you times the whole thing by 9, this 9 goes. So you just have 35t plus 45t is equal to 480. Oh, not 480, sorry. 4,320. Because 480 times 9 is just 480 times 10, which is 4,800, but take away 1,420, or 4,320. Okay. Now, 35t plus 45t is 80t, and that equals to 4,320. Then you divide both sides by 80. And so t, remember t, we defined it early on. T is equal to 1 kilogram of tomatoes, and that's what the question even asks. Work out the cost of 1 kilogram of carrots and the cost of 1 kilogram of tomatoes. So if you do this, it's just 432 divided by 8, because I've cancelled out the zeros. Bus-stop method. Bus-stop method is always amazing. How many 8s go into 4? None. How many 8s go into 43? 5. What's left over? 3. How many 8s go into 32? 4. So the cost of 1 kilogram of tomatoes is 54 pence. Okay, I'm going to rub my working out because I don't have space, but you don't do that in the exam. So now that you know T is equal to the cost of 1 kilogram of tomatoes is equal to 54 pence, we can come back to our original equation. Now, you can plug it into either one. It's up to you. Let's plug it into the first equation. So 7C is equal to 5. Sorry. So 7C plus 5T, but T is equal to 54. So 5 times 54 is equal to 480. So 7C, 7C plus 5 times 54 is 270 equals to 480. And then you do 7C is equal to 480 minus 270. So all we're doing is basically solving. And of course, that's going to be, so 7C is equal to 210 pence. Divide both sides by 7. And the cost of 1 kilogram of carrots, 210, so C is equal to 210 divided by 7, which is 30 pence. And those are the final answers. Okay, everybody, let's move on to question 19. Okay, everybody, for question number 19, please pause the video, have a go. Whenever you're ready for the answers, you can press play. All right, question number 19. Now, my friends, question 19 is one of those higher probability topics. It's really good if you go over it because you'll recognize the question straight away when it comes. But if you didn't recognize it, you could still do it just using initiative. You know, if someone asks you, if I flip a coin 300 times, right? What's the probability that I'll get heads? So what is the probability that you'll get heads? It's a half times the amount of times you're going to flip it, right? It's called higher probability, the product rule, or something like that. When you guys can search the topic. I'm sure you'll find it. But it's under higher probability and it's called product rule or something like that. But you don't really need to go over the topic. Suppose you haven't gone. You know, my point is here, sometimes you come across a question in an exam. Don't straight away think, I don't know this. I haven't studied this. Try to use your initiative. Just math it out. So look, the menu in a restaurant has starters, main courses, and desserts. There are 5 starters, there are 12 main courses, and there are X desserts. There are 420 different ways to choose 1 starter, 1 main course, and 1 dessert. Okay, work out the value of X. So there are 420 different ways I can. So if I go in, I can either choose one random egg. I can choose 1 random starter. I can choose 1 course, and I can choose 1 dessert. And there are 420 different ways I can do that. So I'm going to do 5 times 12 times x is equal to 420 different ways. It's only worth 2 marks, this question. So 5 times 12 times x is 60x, and that's equal to 420. And then you do divide by 60 on both sides. And then you get x is equal to, you can cancel out the zeros. 42 divided by 6 is 7 centimeters. Sorry, it's just 7. X equals 7. So there are 7 desserts. Okay, that's the final answer. Let's move on, everybody. Okay, everybody, we have question 20 here. Okay, now this is a typical functions question. I've got a beautiful set of lessons on this, which I might upload at some point to my YouTube channel. Question 20, right? So they've asked us to find the inverse function of g of x. So what you do is, it's very simple. You write, usually when you're writing out functions, you write y equals something. So you write the function y equals the square root of x plus 2 over 5, right? And then you swap the y's for the x. So x equals the square root of y plus 2 over 5. You see, I've just swapped them. I'm sure you must have done this topic, right? So you times both sides by 5 to cancel out that 5. So you're going to end up getting 5x is equal to the square root of y plus 2. And then you minus 2 on both sides. So you're going to get 5x minus 2 is equal to the square root of y. Then you have to square both sides. So 5x minus 2 all squared is equal to y. And you've almost finished. You can write it as y equals 5x minus 2 squared. But at this point, you just need to expand. So y equals 5x minus 2 multiplied by 5x minus 2. And if you do this, you should get y equals 25x squared minus 20x plus 4. And that is the final answer. Then you just plug it in. You just put in the answer. Okay. Just going to rub this out because I need space, but you guys don't rub it out in your exam. So the final answer for part 1 of this question 20 is 25x squared minus 20x plus 4. Now, solve g of x equals 3. So you have to get f of x and plug it into g of x, right? So f of x is what? 3x plus 4. So you have to plug in g of 3x plus 4. So you see, I'm plugging in this into there. So you're going to end up getting the square root of 3x plus 4 plus 2 over 5. Okay, everyone? And then what do we do? Well, we need to equal it to 3 because that's what they've told us to do, right? So I'm just going to rub this out because I need space. In fact, I can make this smaller. So I'm going to have to equal this to 3. So I have 3x plus 4 plus 2 over 5 is equal to 3. Then you multiply both sides by 5. Sorry, by 5. So you're going to have 3x plus 4 plus 2 equals 15. Because you see, I've multiplied both sides by 5 to solve this. They want to know what x equals. So now I minus 2 on both sides. So I'm going to get 3x plus 4 is equal to 13 because I've minus 2 on both sides. Then I square both sides. So the square root goes. So I've got 3x plus 4 is equal to the 13 squared, which is 169. And then I'm minus 4 on both sides. So I'm going to have 3x plus 4 is equal to minus 4 is equal to 169 minus 4, which is 165. So 3x is equal to 165. Then you divide both sides by 3. And then you can just use the bus stop method because 165 divided by 3. Always use the bus stop method. The bus stop method is beautiful, guys. And everyone should be good at it. How many 3s go into 1? If you're not good at the bus stop method, believe me, go get good at it. And I promise you'll thank me later. You should be thankful to God, but that's fine as well. You can... Anyway, let's not get sidetracked here, okay? How many 3s go into 1? None. How many 3s go into 16? Because everything is from God, not from people. All your success is from God, my friends, okay? How many 3s go into 1? None. How many 3s go into 16? 3. Let's do this in red. 3. What's left over? Am I doing this properly? How many 3s go into 16? Sorry, guys. I was about to flop this. How many 3s go into 16? 5. What's left over? 1. How many 3s go into 15? 3. So the final answer is x is equal to 53. This should be correct. So x equals to 53. Just checking. I didn't make any mistakes here. No, I believe I didn't. Okay. Let's move on to question 21. And of course, it's a circle theorem question. I was just about to rub out my working out. I'm sorry. It's just, you see, it's just rushing, guys. Don't rush in an exam. Just don't rush. 165 divided by 3 ml is 55. So how many 3s go into 15? It looks like I don't know how to use the bus stop method. How many 3s go into 15? 5, my friends. So the final answer is x equals 55 for 20B. Okay. So here, x equals 55. Let's get this circle theorem question now. If my students were here, I'll be finished, mate. Okay, let's move on. Okay, question 21. I'm not going to lie. Even as a math tutor, circle theorems always get me, man. They always get me. So pause the video, have a go at this question. Whenever you're ready for the answers, you can press play. So work out the size of angle ADC. I'm not trying to put you off, but it's just one of the things that you got to practice a lot. And so it's worth having a practicing because it's always worth like 4 marks in the exam, right? I'm just bad at it because I'm just generally, even during my degree, geometry wasn't my forte. It wasn't my thing. But let's do it anyway. And I think I've got this right, but I haven't got a real mark scheme in front of me to check. Work out, trust me. Just let's go. Okay, let's go. Work out the size of angle ADC. So what ADC? So they want us to work out that angle there. Okay, remember it's always the letter in the middle connecting those points. So they want us to calculate this angle here. Now, I mean, I don't know. I'm really thinking that, of course, now, what I'm thinking, the plan is, right, that angle plus this angle, right, plus this angle here should add up to 180 because, well, angles on a straight line add up to 180. I know for a fact that this angle here is 90 degrees. So I'm going to start off by telling the examiner angle ODE is equal to, so that angle there is equal to 90 degrees as angles on a straight line equal 180 degrees. No, sorry. What am I doing? Imal. Sorry, guys. Some guy was coming out of his car and I got distracted. Right in front of my house. ODE is equal to 90 degrees as tangent meets radius at 90 degrees. Tangent meets radius at 90 degrees. Okay, cool. Now, to be honest, look. I don't know where to go from here. But you see, I think that this is a right angle triangle here. I think it is, right? This should be a right angle triangle. And so, I mean, look, if, right, because I'm thinking of many different circle theorems right now. Just look at that. Use your initiative here. That looks like 64 degrees, doesn't it? Now, I know that this is not 64 because it just, I know you might be thinking, oh, angles in the same segment are equal. But look, this just doesn't look, that is not 64 degrees, man. Look, if I drawed a perpendicular line, right? If I drawed a perpendicular line to this line here, right? That'll be like, what, 90 degrees? The whole thing? So there's no way just that bit is 64. So I'm not going to sit there and say, oh, that's 64 degrees. I'll laugh if I'm wrong, but you know. And I know this can't look like 51 degrees. So I can't say, oh, because that's 51, that's 51. Or can I? I don't know. But there's two things I'm thinking. Number one, I can say, well, vertically opposite angles, right? So if I know that this is 64, let's just bring up the circle theorems real quick, right? Let me bring them up. 1 second. Now, I've got these circle theorems from, of course, it's a screenshot, so my face is there. I got these from Third Space Learning or something like that. It's called Third Space Learning. Yeah, these guys. I got it from these guys, right? They're super cool. I shouldn't really be. I don't know why I'm advertising other tuition companies right now, but let's just keep going. So I got this picture from there. Now, look at this rule here. Angles in the same segment are equal. In fact, let's see if we can just give me 1 second. Yeah, let's really think about this, guy. Okay, look, I've had a thought about it, and look, I'm thinking either this is 51, right? And if that's 51, right, if that's 51, that's 90. It's a simple case doing 180 minus 51 minus 90. Or this is going to make me sound like a real rookie. Yeah, I'm to be honest, I don't think of any other way. I can't. Or this is a right angle triangle. And you can't just assume it's a right angle triangle. That's the problem. We can't just mathematically say, yeah, that's a right angle triangle. Like, how can we prove it? How can we say that that's a right angle triangle? Because, of course, if it is, this is 90 degrees, then you do 90 plus 64 and minus that from 180. Then you have the angle and you're pretty much done. So I don't know. I honestly don't know at this point. So what we're going to do, I'm just going to do the answer how I would have done it in an exam, and then someone in the comment section can help me. Because right now I can't see anything else, but I'm going to pause the recording and try think for a few seconds. Yeah, guys, I'm just going to go with my gut. If I'm wrong, you guys can tell me in the exam. Tell me in the comments below. I'm going to say this is 51 degrees, even though it doesn't look it, but whatever. No, that's just going to get me the wrong answer. I know it is. I'm going to go back to thinking. Yeah, guys, I just don't know. I don't know. And I'm not going to write down anything because I know it's wrong because I've done the calculations and this comes out to be something like 39 degrees, which is impossible. It's clearly bigger than 39 degrees. I'm pretty much giving up on this question. And I wish my students were here to help me, but they're not. Let's keep going, everybody. Let's move on to question number 22. Question 22, everybody. Let's do it. This is a typical 3D trig question. Now, we've been told that AF, stay with me, it's not that difficult. I promise 3D trig is not that difficult. You need to spend time learning it. We've been told that that is 6.8 and the FC, where's F? F to C, that line there is 13.6. If you draw the line diagonally through the base, you see you have a right angle triangle. It's in 3D, but it's there. You just have to see it. So look, I'm going to sketch it here. I know that this is A, this is F, and this is C. They've told us that this is 13.6 and that this is 6.8. Okay? And they've asked us to find this angle here, right? How do we do it? Well, we've been given the opposite and the hypotenuse. Now, you might be thinking, Mal, how on earth are they giving you a 3D trigonometry question in a non-calc paper? But it's actually really easy. Use SOHCAHTOA, right? As we know. So we've been given the opposite and the hypotenuse. So sine theta is equal to the opposite, which is 6.8 over 13.6. So sine theta equals 6.8 over 13.6 is a half. What angle can we put in there to give us a half? Well, you should remember how to find exact trigonometric values using the finger method or the hand method, otherwise known as, actually, it is called the hand method, but more like here, we've got a paw. So this is 0, and I would always write this down. Don't try sit there in your exam, like sketch a hand. Don't try sit there in an exam and do this because you're going to spend too much time. 0, 30, 45, 60, 90. So if you notice, if you remember the finger method, if we go to 30, we've got one finger on the right. So root 1, remember you always root it over 2. And of course, so if you go to sine 30, right? If you go to sine 30 degrees, you get root 1 over 2. And root 1 is 1. So 1 over 2 is sine 30. So that is it. Sine 30 is equals to half. So therefore, the angle theta must equal to 30 degrees. And that's the final answer. Beautiful question. If you didn't know the finger method, which I highly recommend you go learn, of course, I've got I've got a beautiful set of lessons on it, but it's up to you if you want to subscribe to our platform, our tuition platform. But yeah, the answer is 30 degrees. Okay, a third question. Let's do it. I love third questions. Let's have a go. Now, question 23. This is basically just rationalize the denominator, isn't it? It's going to be a bit long-winded, but let's start. 3 root 3 over 4 minus root 3. We're going to have to sort this out first by rationalizing the denominator. So times both sides by 4 plus root 3, the top and bottom, I mean. So you're going to get, oh, this is a bit long, to be honest. You're going to get 3 root 3 times 4. So it's going to be 12 root 3. And then 3 root 3 times root 3. So it's 3 root 3. So it's 3 times root 3 times root 3. And of course, root 3 times root a times root a is a. So root 3 times root 3 is just 3. 3 times 3 is 9. I'm pretty sure I've done that correctly. So you're going to have 12 root 3 plus 9. I'm sure this is correct. And of course, you can check these kind of questions on the calculator, can't you? So I might be cheeky and go check later on. But let's keep going. So that's the numerator. In fact, let me just check. No, I'm positive. I should stay confident. Let's keep moving. Then the denominators, when we times these out, it's the difference of 2 squares. So you're just going to get 16 minus 3, which of course is 13. So you have so this bit here, I've rationalized the denominator. I've got 12 root 3 plus 9 over 13. And you're minusing that by 2 root 3 over 3. I've already rationalized the denominator for this one here. It was quite quick, wasn't it? Because it's just 2 over root 3 times by root 3 top and bottom. So you're going to get 2 root 3 over 3. What do we do now? Well, we have to find the lowest common multiple here, which is 39. And that's why I'm thinking I'm making a mistake, because usually they'll make it something easier. Have they? Give me a second, guys. Let me check. In fact, let's make it fun. Let me do the whole thing, and then we'll check the answer later on a calculator, okay? So how many 13s go into 39? 3. So if you times this by 3, you're going to get 36 root 3 plus 27, right? Minus, and then you'd have to times this by 13. Minus 26, 3, because how many 3s go into 39? 3. Sorry, how many 3s go into 39? 13. So 2 times 13 is 26 root 3. So now we're just collecting like terms. 36 root 3 minus 26 root 3. No, this is looking correct, to be honest. This is looking correct. So you're going to get 10 root 3 plus 27 over 39. Mal. You know the 27, let's just leave it like this. Let's go check on a calculator. In fact, I want you guys to see my live reaction. So 3 root 3 over 4 minus root 3 minus 2. Oh, what have I done? Oh, yeah. So minus. So 3 root 3 over 4 minus root 3 minus 2 over root 3. 27. Oh, we got it correct. Awesome. We just got it the other way around, but we got it correct. That's nice. Let's move on, everybody. That's made me happy. Let's go over to the final question, and that's it. We're done. Quickly, moral of the story. I thought I made mistakes because I was getting dodgy numbers, and they usually make questions easier than that. But I stuck to it, you know, like I was, because I knew, like, guys, moral of the story is check your work, but be confident as well at times. Now, the final question. Now, this looks like a find the region kind of inequalities question. So let's do it together. Pause the video. Have a go at this question. Whenever you're ready for the answers, you can press play. Now, for this question, guys, number one, you should realize there's a difference of square situation happening here, right? This question is not difficult, but let's just do it. So you're going to get 2x minus 5, 2x plus 5, right? I've just factorized it. Difference of two squares, not that hard. That's less than 0. And so the two factors are 2x minus 5 equals 0. So add 5 on both sides, and x will equal 5 over 2. I've just solved for x. I haven't done. In fact, let's take it easy. So we added 5 on both sides. So 2x equals 5. And divide by 2 on both sides. 2's cancel out. X equals 5 over 2. Because both factors are the same, x equals 5 over 2. Oh, no. Sorry. One of them is going to give you x equals 5 over 2, and what the other one is going to give you x equals minus 5 over 2. So if we were to sketch it, right? All I did, guys, I also solved this bit, okay? So if we were to sketch it, we would get this. Forgive me if my sketch is terrible. I'm doing it with one of these things. So this is minus 5 over 2. And this bit here is 5 over 2. Those are the two roots. Those are the two solutions. And because it's less than 0, we're looking for the values in between. So x, right, is greater than minus 5 over 2, but it's less than 5 over 2. That's basically 2.5, isn't it? In fact, let's put the actual values on them. Just for now, so you can appreciate what I'm saying later. And this is 2.5. Now, for this one here, okay, I'm going to like make this small, right? Let's put it over here. For this one here, you're going to have to be good at your algebra. So it's minus 3x squared minus 5x plus 12, and that is greater than 0. I'm going to times this whole thing by minus 1, and I'm not sure if that's like chickening out, but I think it's allowed at this point. So I'm going to have 3x squared plus 5x minus 15, but the sign also changes to less than 0. And then if you solve this, what? How did I make that into a 15? Sorry, guys, there was supposed to be a 12 here. I was about to say, man, where did the 15 come from? See, guys, you can miswrite the question and really mess yourself up. There's a 12 here. So if it's a plus there, right, and we times it by minus 1, then it's going to be a minus 12 here. Do you guys see? I hope I haven't confused anybody. I just times this here by minus 1. And so the sign also changed. So now 3 times minus 12 is minus 36. Right? And so this is the bit where I might mess up. And I've done this question earlier in my book. Like, not in my book. I was just, like, before I press play again, I just quickly had to go on a sheet of paper. And I think I've found myself in a bit of a predicament. Let me double check. 1 second, guys. It's okay. I was just bugging out. I'm fine. So basically, something plus something gives you 5, but something times something gives you minus 36. And of course, the solution is going to be, and if you find this difficult, go learn it. I mean, could join my platform. I feel like I explain it on my course is quite good on quadratics. So it's going to be -4 plus 9 and -4 times 9. So what I'm going to have 3x minus 4 and 3x plus 9. And that is all less than 0. And the sketch is going to be very interesting here. So watch. So the two factors, you got 3x plus 9 equals 0, right? And of course, this before you even do that, you're supposed to simplify this, aren't you? So you're actually going to have 3x minus 4, x plus 3. So this factor is just called equals x minus 3. And this one here is going to give you x equals 4 over 3. So you really need to concentrate here. So if I sketch the graph here, right? I'm going to have 4 over 3, which if it's a top-heavy fraction, it's actually 1 over 3. It's like 1.33, which is roughly there. And then minus 3 is roughly there. Oh, whatever. But okay, just stay with me. Pretend this is cool, okay? So minus 3 is here. And 1.33 is there. 1.3 recurring. And again, it's less than 0. So for this bit, for the second equation, this one, I'm going to have x is greater than minus 3, but less than 1.3 recurring. So you're going to have to consolidate between these two. So find the set of possible values for which x equals these two equations. You're going to have to consolidate. So you're going to have to say x, so final answer. And I believe this is the final answer. Please do correct me in the comments if I'm wrong. I don't have anything to work off. I've tried looking. I can't find it. So my final answer is x is greater than, because you think, imagine if I told you I'm thinking of a number, it's greater than minus 3. But then I told you, oh, but it's also greater than minus 2.5. So it's also greater than minus 2.5, right? But I told you it's less than 2.5. But then I also told you it's less than it's less than 1.3 recurring. This should here be the final solution. Okay, I'm really sorry. That should be the final solution. This question, I really don't want to upload this until I figure it out. I really don't. In fact, before I end this lesson, you never know, God might just put it in my mind. Let me just look at it one more time using all the circle theorems. I don't see any parallel lines there. Why do these circle theorems always do this to me, man? Give me a second. Do you know what? Whatever, man. That's 90 degrees. So I'm going to tell the examiner, I'm just going to do it now. Angle ODE is equal to 90 degrees as tangent meets radius. Tangent meets radius at 90 degrees. Cool. Then I'm going to say that is a right angle, even though I can't mathematically prove it, but whatever. That's a right angle triangle. So I'm going to say 64 plus 90 is equal to 154 degrees. Then I'm going to say, therefore, angle ODA must equal to 180 degrees minus 154 degrees, which is 26 degrees, even though it doesn't look like 26. Because look, if I drawed a straight line up here, if I drawed actually that could be 26 degrees. Whatever. Anyway, then I'm going to say, finally, angle AD. So I'm going to say 90 plus 26 is equal to 116 degrees. Right? Because remember, this angle here was 90. And that angle there was 26. So then I'm going to say 180 degrees minus 116 degrees is 64 degrees. Therefore, this angle here The final answer, ADC, is equal to 64 degrees. I'm pretty sure, because the fact that I can't prove that this is a right angle triangle is bugging me. And I'm pretty sure there's something so simple that I'm missing that when I see it, I feel like I'll probably feel like face palming myself. Thank you very much, everybody. This has been the last part. Let me know if you want me to upload more exam video solutions. Obviously, look, for other exams, you'll have the mark scheme, so I can kind of work backwards, right? And I know 100% I'm right. But for this paper, pretty sure I've done everything correctly. But if I have done anything wrong, please do tell me in the comments. Thank you very much, everybody. Bye-bye.